So let's look at group 1. So what we're going to do now is we're going to take just a little deeper look at each of the blocks and look for some commonalities, and we're also going to look and see what families we expect to find in those blocks. So we're starting here with the S block, and the S block is known to be very reactive. Group 1 is found right here in this first column of the periodic table, and group 1 is known as the alkali metals. These alkali metals in group 1 are very highly reactive because if you're in group 1, you're actually very close to being a noble gas. You can see that if you just connect the two sides of the periodic table. So group 1 is as close to being a noble gas as group 17 is. And in some ways, group 1 is even closer to being like a noble gas because it only needs to give up an electron. And certainly giving up something is much easier than locating, finding, and stealing something, right? If your whole life was going to be perfect when you gave away this one marker, boom, it's gone, right? But if your whole life was going to be perfect when you found this one marker, that might be more difficult, right? Either way, we're trying to get to that perfect valence configuration with 8 electrons in our valence shell. But the alkali metals only have to give away 1 electron to become like that. Because of that, we rarely find them pure in nature. They have formed their ionic compounds because they just give up that electron. They react what we call violently with water. They're going to react really strongly with water. They're going to give water, because it has oxygen, they're going to give water all of their electrons. Group 2 is slightly less reactive, slightly harder, denser, and stronger than group 1. Group 2 are called the alkaline earth metals. So group 1, alkali metals, group 2, alkaline earth metals, and group 2 has 2 electrons in their valence shell. This means that they are also close to becoming perfect, but they would have to give up 2 electrons in order to become so perfect. And so it's a little harder to give away, to find a home, rehome 2 electrons. So they are still quite reactive, so reactive that they're still not found pure in nature, but they are less reactive. It's less of a violent reaction from the group. Moving on across the periodic table, we find the P block. So as we move across our S block over here to this blue block, this is the P block. These are groups 13 through 18. Remember, 18 are like the noble gases. They have that stable octet, the full valence shell. And so as we get closer and closer to that place, we're going to find that these elements become more and more reactive. The P block is actually split right down the middle with a stair-stepping line. And I'd like you guys to add that stair-stepping line to your periodic tables that you printed out and colored like this and have been adding notes to. To add the stair-stepping line, you're going to start in the top inside corner on the inside of boron. And that stair-stepping line is going to step down and over all the way down through the P block. So I have just added my stair-stepping line, starting here from boron and stepping its way down and over across the periodic table. And what that's going to do is it's going to separate what we call the left-hand side from the right-hand side of the periodic table. So we would call this section over here the left-hand side, and the right-hand side is like above and to the right of this stair-stepping line. So above and to the right of the stair-stepping line, we're going to see all of the nonmetals. Nonmetals are a type of element on the periodic table, and they have certain qualities that we'll be talking about later on. But all of the nonmetals are contained above and to the right of the stair-stepping line. all of the metals are contained down to the left. So everything on the bottom of the P block here and all the way in the D block and S block, they're all considered metals. And you can remember that because you'll find metals you recognize over there, like gold and silver and iron and titanium and platinum. And these are all metals that we recognize. And so we know that over here, these are the metals, which means the other side must be the nonmetals. And right along that stair-stepping line, I'm not going to ask you to memorize which ones are which, but right along the stair-stepping line, we see some metalloids. They're kind of like metals, but then they're kind of like non-metals. Metals are known for being good conductors of electricity. Non-metals are not. And so we see this kind of change. Metalloids would be semiconductors. They would be kind of metallic, but they would also be a little bit brittle like the non-metals are. So they're going to have these intermediate characteristics, the metalloids. And so it's not really like a hard line transition. It's a little bit like a gradient as we move across. So things that are over here are the most metallic in character. And as we come up here, we are the least metallic in character. For the P block, you can predict the number of valence electrons by doing the group number minus 10. We're going to need to know how to do valence electrons, predict valence electrons in our next chapter. So I just want to do a little practice with you. So take out your periodic table and take a look at it and look at sulfur. Find sulfur. Sulfur is atomic number 16. If you look at what group sulfur is in, it is in group 16, and it has 16 minus 10, 6 valence electrons. Germanium is in group 14, and so it has 14 minus 10 gives me 4 valence electrons. Selenium also has 6 valence electrons, just like sulfur, because it is also in group 16, just like sulfur. 16 minus 10 gives me 6. So everything in group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. 8. Group 18 has 8 valence electrons, and that's what gives them their stable octet. So we're going to look at the famous groups that are in the P block and get to know those. So in the P block, group 15 is known as the nitrogen family because nitrogen is the most famous member within it. Group 16 is known as the oxygen family, again, named for its most famous member. Group 17, however, is called the halogens, and the halogens are well known because they are very reactive. They are so reactive because, once again, they are so close to those noble gases. The noble gases have that full valence shell, that full stable octet, and so everyone wants to be like them. All something in the halogen needs to do is gain a single electron, and it is like a noble gas. So those halogens are on a mission. They are ready to gain that electron, to find it, and to grab it up for themselves. And so our P block is full of groups that all have specific names. There are 2 special elements in the P block, hydrogen and helium. Hydrogen is unique because it has a 1s1 valence electron. So it has 1 electron in its valence shell, which makes it like group 1. But it also almost is full because for hydrogen, it is full with 2 valence electrons. So it's also kind of like a halogen. It's quite reactive. Helium, same kind of deal, has a s2 electron configuration. And so in that way, it should be right over group 2 with the beryllium and magnesium and calcium. But it turns out that it also, because 2 is the most it can have, having 2 for helium makes it also stable. So we put helium as like a noble gas. And instead of having a full octet, we say that helium has a full duet. If you've ever sung a solo before, you know that if you sing a solo with someone else, if it's just the two of you singing, we call that a duet, two. So helium has a duet instead of an octet because it has 2 electrons in its full valence shell instead of 8 electrons in their full valence shell. The next part of the periodic table is called the D block. The D block is also called the transition metals because they're transitioning from the S block metals to the P block metals. And so once again, we have this kind of gradient of change where they're becoming less and less metallic in character as they move over towards the stair-stepping line that separates the metals from the non-metals. These transition metals are good conductors. They have a high luster. We like to use these in jewelry and in structural material. They're really nice, solid metals. You're going to see things like gold and silver and platinum in here, all things that we use in jewelry making. They are less reactive than groups 1 and 2, and because of that, they can be found pure in nature, which of course you know, because like the gold rush, right? So we know that you can find gold pure in nature. The last block to talk about is the F block, and the F block has 2 different groups, the lanthanides and the actinides. These are 2 different groups of elements. They're called, sometimes this group is called the inner transition metals because remember, they go within the transition metals. So you've got the transition metals between the P block and the S block, and then you've got the inner transition metals that are kind of within the D block. Remember, this F block gets added right here to the periodic table. So it comes right in the middle of the transition metals. So we call it the inner transition metals. And the F block is such a big block of elements, and if you put it within the periodic table, it would make the periodic table too long and skinny to fit on a piece of paper. And so one of the functional reasons that we pull the F block down out of the periodic table is so that it will fit nicely on a page. So we have just covered all of the families of the periodic table, and I really want to encourage you guys to spend some time making sure you know these terms, because I might say, oh, well, halogens do this, or the alkaline earth metals are known to do that when we're talking about trends, and that requires that you know about these different families. So we have the alkali metals, remember, very highly reactive, alkaline earth metals, slightly less reactive. We've got the halogens, very reactive. Remember, all of them are reactive because they're near these noble gases, which are very stable. Then we have the oxygen and the nitrogen family. We didn't talk about the carbon and boron families. They don't really come back through our general chemistry survey. The transition metals, which are transitioning from the S block over to the P block, and then our F block down here, which we can call the inner transition metals, and we can see their position kind of moves up within the transition metals.